The next section we're going to talk about is aspect ratios, and aspect ratios in the media, to be more specific. We're going to be dealing with television screens or devices that have a screen, and we have one image projected onto another image. We'll talk about cameras and the pictures that we try to resize the image to fit, like an 8x10 or 11x14, etc. But we're dealing with the aspect ratios of rectangular objects here, and the width to height. Notice the width here is the largest dimension. So if you always make the width the largest dimension, everything that we're talking about will fall pretty seamlessly in line. We're going to express our ratios as something to one. And I've already talked about this in the first section of Unit 1. We're going to keep it true. So the aspect ratios are expressed as something to one. Just simply take the width divided by the height to 1. Major concepts we're going to talk about: constant of proportionality or scale factor. We'll also use Pythagorean theorem and use that scale factor in Pythagorean theorem and similar figures. Now, these two will give you the same result when calculating the constant of proportionality. It's just one is more of a geometric concept and one is more algebraic in the way that it's executed. And so if we talk about television screens, we have a full screen image that's 4x3 and a widescreen image that's 16x9. If I was to simplify these down to 1, 4 to 3 would be a 1.33, and the 3 repeats ratio to 1. And then the 16x9 would be a 1.78 to 1 aspect ratio. And then we have several different examples, several different things that we're trying to figure out using these aspect ratios. And so we'll have a couple of examples to figure out the diagonal or the dimensions of a television if we know the diagonal dimension. We'll figure out how many pixels we lose when we take an image taken on a camera with one aspect ratio and change it to another aspect ratio, such as creating an 8x10 picture. And then we'll also see, when those black bars at the top and the bottom or the sides of a television screen, we'll see how much area is occupied by the screen's image and essentially how much area is lost or goes unused on that television screen. In this example, it's one of the first examples in the worksheet. We have finding the dimensions of a 25-inch television screen with a 4 to 3 aspect ratio. Now, sometimes you might not even say 4 to 3 because it is told to you, and it is probably going to be taught in class, that a 4 to 3 ratio television is a full screen. So we may not even have the ratio given. It may just say full screen, and that is defined to be a ratio of 4 to 3. So here, the two different ways that we can do this is we know that there is some scale factor between the diagonal of this television and the width and the height, the ratio of a smaller triangle or smaller rectangle. So we have the width of 4 times the constant of proportionality, k, some number that we multiply both by 4 and 3 to get this 25 whenever we do Pythagorean theorem. So we have 4 times k squared plus 3 times k squared is equal to 25 squared. Now this here will give you this picture where 25 is the diagonal and 4 times k is the width, 3 times k is the height. Some number to multiply by both dimensions to get the actual dimensions of this television. And this here is a right triangle, so this is Pythagorean theorem. And so what we'll end up getting is 16k squared plus 9k squared equals 625. And then you can combine these two because they're both a term with k squared. So this is 25k squared equals 625. Divide both sides by 25. And then you get k squared equals 25, which tells us k is equal to 5. And so that's using Pythagorean theorem. Now that's for maybe your more advanced students. They might be able to see the algebra in that as opposed to seeing the scale factor in similar figures. So if I show the scale factor in similar figures, it will look something like this. Well, you have this triangle that we do not know the width and the height of this 25-inch television screen, but we do know the width and the height, but we don't know the hypotenuse of that ratio. I call it the ratio triangle. Well, so we can do Pythagorean theorem real quickly. 3 squared plus 4 squared is 25. Square root of 25 is 5. So here, the hypotenuse of this rectangle, it's also a special right triangle, 3, 4, 5. Well, then we got to figure out what number do we multiply to get 25 to match the diagonal or the hypotenuse of this, the actual size television. Well, here K is equal to 25 divided by 5, which is 5. My width is 4 times 5, which is 20, and my height is 3 times 5, which is 15. And so that allows you to use similar figures to get your scale factor, or Pythagorean theorem to get your scale factor. The next type of thing we have is a TV screen with an image on it that doesn't have the same aspect ratio. So in this case, we have a 4:3 screen that is projecting a 16:9 image. And what we want to see is the percent of the screen occupied by the image. So how much of this screen do you see this image? Well, the very easy way to do this is to take the aspect ratios and simplify as a ratio to 1. And we've already done that. The 4:3 is 1.33 repeating, and 16:9 is 1.78. The very simple way and consistent way to do this throughout any type of problem is to take the small ratio divided by the larger ratio. You have 1.3 repeating divided by 1.78, and you get 75%. Now, there's other ways that you could do this, but this is going to be the most consistent way. And then also, the converse to this problem is what is the percent of the screen that's wasted or that goes unused. Now, we might see that it's wasted because it's not used, or we might see the percent of the image that's wasted because it goes beyond the screen. So it'd be something like this. Here's what you see, but here's the actual image. So this right here would be waste. And this right here is waste because it's part of the screen that's not used. It will give you the same results if you do it this way, except there's one more step. To percent wasted, you take the small ratio divided by the larger ratio, you get 75%. Well, then you got to take 100% away from 75, and you see that the percent wasted in this case is 25%. So we're either going to find the percent wasted or unused, or the percent occupied by whatever the ratios are that are given to you. And guys, in this worksheet, there's more ratios than the 4:3 and the 16:9 because entertainment has broadened its scope, and now we have 2.35 to 1, 1.85 to 1, and so on. There's so very many different aspect ratios being used that the extensions to this problem go far beyond the examples I've given you.